Hello everyone. In this video we will be studying about the diesel cycle. Diesel cycle is also an IC engine, which by definition says that the engines in which the combustion of fuel takes place inside the engine cylinder. There are two kinds of IC engines. One is petrol engine, other one is diesel engine. The main difference between the two is that in IC in the petrol engine we are supplying the mixture of air and fuel during the suction stroke, whereas in diesel cycle we will be supplying only the air during the suction stroke, and this air is compressed to very high pressure, and at the end of the compression stroke the fuel is injected into the cylinder, hence the combustion begins. So diesel engine works on diesel cycle. In diesel cycle the fuel is ignited by heat generated during the compression of air in the combustion chamber, into which fuel is then injected. The fuel is injected at very high pressure. The construction of the diesel engine and petrol engine are almost similar, but the only difference is that the cylinder size of diesel engine is much bigger than the petrol engine. This is because the compression stroke has to achieve very high pressure during the compression stroke, and the compression ratio of diesel cycle is 22:1, whereas the compression ratio of Otto cycle is 6:1 or 10:1. The diesel cycle also has 4 strokes, as I have explained in the previous video. For Otto cycle it has intake stroke, compression stroke, ignition stroke and exhaust stroke. In the PV diagram, as we can see the diesel cycle here, the point number 1 represents the end of suction stroke, and the air is taken inside the cylinder and it is ready for compression. As the piston moves from bottom dead center to top dead center, the volume decreases and the pressure increases, and this process is called as isentropic compression. Isentropic means it is also called as adiabatic, where no heat is added into the system or it is rejected from the system. At the end of the compression stroke, at point number 2, the fuel injection begins, and the fuel is injected at constant pressure. So it is a constant pressure heat addition process. And at point number 3, the fuel injection stops and the piston moves downwards, because of which we can see there is a decrease in the pressure and volume increases. From 3 to 4 it is isentropic expansion or adiabatic expansion, where no heat is added to the system, no heat is rejected from the system. And at point number 4, the exhaust valve opens and exhaust gases moves out of the system, and the heat is rejected to the system, rejected out of the system to the surroundings. In the TS diagram we can see the same process that is represented here.